Great. Okay, so we are going to get started. Today, we're going to do our last sort of R tutorial before we get into the main meat of the course. And we'll cover a little bit more functionality, but most of the stuff today is actually going to be looking at more advanced packages that I think are generally useful for data analysis and visualization. This is actually a little bit different from what I've taught in the past because I've mainly focused on base packages. But here, I think, again, due to the lack of the old course that taught R, I think it'll be handy to learn a little bit about some pretty common packages that are used that I think are pretty helpful for this type of stuff. Okay, but before we get there, we need to finish up with the last data structure. So if you remember from last time, we covered vectors, matrices and arrays, lists, and factors. And then the last, probably most useful one is something called a data frame for those who aren't familiar. So this really is kind of the workhorse. If you think about tables and manipulating data, kind of really the equivalent of having a table in Excel. This is the framework that R handles that in. So let's go ahead and look at how you would go about creating a data frame. So I'm going to make some hypothetical data to start off with. So data frame is the function. Here actually we can see the inputs that you would have, and the sort of ... at the beginning is how you enter the data. So in quotes, you can put the name of the column that you want, and then you're going to want to put in the vector of values for that column. So if we have names, I'm just going to put in student 1, student 2, student 3. And then let's put in ages, 24, 27. We can have, let's say, a gender column. And we'll have something like a math score column. Oops. And a verbal score column. This might be something like a SAT type test. Okay, and so if I go ahead and run this, we can see it showing up here in the global environment. I can take a look at the table. So here we've created this table with names, ages, gender, math score, verbal score. So this is kind of the basic way of creating this data frame. It's the name of the column followed by the vector of input values. Note in this one, we have 3 values in each column. What happens if we, what happens if we delete one entry? So now you have this column with 3 entries. All these columns have 3 entries except for verbal score, which has 2 entries. And if you try to run this, it'll get an error because one of the arguments implies a different number of rows in this last one here. So you do need to put the correct number of values here. If you don't have the value, you could always put in NA. Okay, so let's take a look at a couple useful functions for data frames. You can have something called summary. Let's see what that does. Here, it will provide a breakdown for characters of the different types of names and genders. And you can see in the characters, it'll actually provide the number of entries of a particular level. If you have more than, I think, 5 or 6, it'll just say other, and it'll list the most, well, actually, it'll just list them in whatever order. You can set it to make it list it by the most common, but we can show that later. And then for the numeric columns, it's going to give a quick summary breakdown statistics of the min, max, mean, and then the first and third quartiles and the median. So this can be a nice quick way to examine like a pretty large data set, and it'll give you a nice sort of rough distribution. You can look at these quantities to see kind of how your data is distributed. So that's one handy sort of summary diagnostic device to look at your data. There's another type of function here called str, and this stands for structure. If I go ahead and run this, it's going to tell you the characteristics about this data set with relation to data types and data structures. So the data frame, it's 3 observations with 5 variables. So 3 essentially rows and 5 columns. And you can check that as before. Just as a reminder, we have used these functions before, but nrow and call is number of rows and number of columns. So there's 3 rows and 5 columns. Okay, going back to the structure, it tells you that names and gender are both factors, and ages, math scores, and verbal scores are numeric. We discussed factors last time, and you can see when I enter a vector of characters into a data frame, it automatically makes them into factors. And there are some benefits of doing that, right? Because it'll allow for certain types of processing. It treats them as categorical variables, but remember there are certain issues with this in terms of manipulating the data, so you have to be careful. As I was mentioning before, it's probably the number one error is factors inside data frames and learning to deal with that. You can actually have an option to load them as characters and not as factors. Let me see if I remember how to do that. Let's see. Yeah, here I can do this little cheat sheet thing to look at the entries, and the one that I want is called strings as factors. And so if I do that and I say false, then once I load the data frame, you can see that it's going to be slightly different for the summary and the structure. So here, it'll say that there are characters in here and 3 rows of characters, which differs right from up here, which tells you the number of entries of each level of the factor. And then here, when I look at the structure, it's now a character instead of a factor, and it's giving the simple entries here. Okay, and so that's one way to deal with that. In the column names, one of the things that you can't actually do, so let me see if this works. Let's say I name my data frame column as a number. Let's see. I may have to do something slightly different. I'm not sure. Yeah, okay, actually, no, that worked. What you'll notice is that it actually reassigns the name of the column into x1 instead of 1. And there are some reasons for why this happens. Generally, it's not good practice to start with a number for your column. And we'll see one of the reasons why it replaces it in just a second. But if you really, really want to, or if you happen to be loading in a data frame that has numbers for columns and you want to preserve that, you can actually do that. There's one of the entries in the data frame is called check.names. So that's literally checking for column names that start with a number and it replaces it with the X at the beginning. And I can do something like this: check names equals false. And if I run this and I look again at my student data, now you can see that the column has preserved its entry as 1 instead of x1. But generally, it's not good practice to do this, and we'll see why in just a second. Okay. Get rid of this. Add a quick note here. Check.names functionality. Substitute numbers for column names. And the other one was strings to prevent automatically making characters into factors. Okay. No questions so far, so we'll keep moving. Oh, I do see a question. What if I want one column of strings to be characters and others to be factors? Yeah, so you can do that. You would have to manually go in and specify. Yeah, I don't think there isn't a good way of denoting and because you're kind of manually specifying which columns you want to be factors and which columns you want to be characters. You'll basically need to import them in as one type. I would recommend importing them as factors and then changing the columns that you want as characters into characters. And I'll show how to do that in a second. So columns as flashback. I'm just going to put a note so I remember to do that. Okay, one more quick function, helpful function for dealing with the data frames. It's called names, and this just provides you the names of each of the columns, and that can be pretty handy if you want to deal with referencing specific columns by like a or referencing names of columns. These three functions, summary, structure, and names, are all pretty handy for manipulating and quickly learning about data sets that you're working with. I personally use these all the time. So I'm sort of presenting these functions as or functions that I think are fairly important and useful. So it'll be good to be familiar with these things. Okay, now let's learn about how to reference data from the data frame. So I have this table, and suppose I want to return the first row. So this is pretty similar to the rules from doing referencing that we learned before. For matrices, if you remember, it goes row, comma, columns, RC. So if I want the first row in the square bracket, I can do this. And it will return the first row. So here we can see the entries of the first row. If you want to return multiple rows, we can do that. In the position before the comma, you want the first two rows, you could do this, and that will return both rows 1 and 2. Remember, that's equivalent to doing something like this, right? You just need to put in the vector of values, and it doesn't need to be next to each other. You can return the first and third row, for example, and you can see that functionality here. Okay, I can also return a column, which is probably exactly as you expect. So if I want to return the second column, I can do that here after the comma. And that will return the vector of values contained in the second column. So here's a pretty common mistake that I make or used to make. If I forget to put the comma, and oftentimes this can happen, especially if you're doing certain types of filters. It doesn't know if you're referring to the row or the column. And so if I run this, it will sort of by default return the first column, but that may not actually be what you want if you want the row. So it's always good practice to include the comma. And we'll get to a more advanced version of data frame later, where called data tables, where you can actually omit the comma, but generally it's again not good practice to do so. Okay, so I see a question, is there a way to get the title of the column printed as well? Yes, there is. And actually that's a pretty important distinction. And I'll show what that, how to do that in a second. Before I do that, if you want a specific point of data from the table, you can do that. So let's say row 3, column 2, and that will be 27. And so we can quickly see that happening here. 27 is the 3rd row, 2nd column. Okay. So hopefully that's pretty straightforward for referencing. Now let's look at a couple different ways of doing referencing as well. So specifically, if I want to do returns of a row. So one of the ways that we did that was doing the index of the column, so 2, but you can actually call it by name as well. And you can do that in 2 different ways. So I can do this operator, and dollar is essentially the way that you are referencing a specific column, and you put the column name. This is where you run into some sorts of issues with column names if you have them as numbers instead of as characters, which is why I put that X before. If you remember when we were trying to load in a column name of 1, it changed it to X1, because if you put a number here, sometimes it can get confused. The other way to do it is actually in the same referencing system here, we're gonna ask for the name of the column, and you put that in quotes here, age. So all of these will return the age column, but there will be something slightly different. Okay, so let's take a look. I'm gonna run this first one, and you can see it's getting returned as a vector. Same thing here, getting returned as a vector. Oops, ages. Oops. Huh. I don't know why this worked though. I've actually never seen that before. Is that right? Ages. Yeah. Hang on. I didn't know you could do that. So if I put AG, no, okay. I guess it you can do abbreviations there. Good to know. You learn something new every day. Okay, so that's the one using this dollar sign, and then here. Okay, so in the same position as where you would put the index, you can actually put the name of the column in quotes, and you get something like that. So let's see, so going back to the question, is there a way to get the title of the column printed? So here you're listing, it's returning just the vector. But actually, if I were to, let's see, I'm actually not sure if this works. Yeah, it does. Okay, so if you don't include the comma, it's going to return the column entry, And the biggest difference is you'll see that this is being returned as a data frame and not as a vector. Okay, and that has some implications for how you would handle and manipulate the data. And so certain types of queries for returning returning values from the table, it's always important to pay attention to the form of it, right? Because these are vectors, but this is a data frame, even though it's basically containing the same data. And in fact, you can, for any of these, you can string together operations for referencing. And so you could actually return, let's say, the first entry of the vector by putting the reference lookup position here. Okay, and so this really is this portion here that I'm highlighting would be exactly the same as doing something like this. Okay, you can imagine that you've just sort of replaced that reference lookup. And so if I run this, it should return the first entry. So you can string together references. Maybe I'll just put that here. Okay. So continuing on, I can, so the handy thing about doing it as a lookup of the column name inside the square is that you can actually look up multiple columns. So here, if I use the dollar operator, I can't return multiple columns. This is only to look at an atomic vector of a single vector. But with the character argument, I can put in a couple different columns here. So if I want to look at ages and gender, it will do that. And notice this time, when you return the columns, because you're returning multiple columns, it has to return it as a table. You can't have multiple columns in a single vector form, right? And so even though the same sort of procedure returns a vector with a single entry, when you have multiple entries for columns, it will return a data frame. And you can I can return a specific value lookup as well. So if I want the second entry of verbal score, works kind of the same way as up here. You have your row reference and your column reference, and it will have this value that we had initially put in, 620. You can actually you can assign values to replace them. So if I were to do something like this, then I've replaced the 620 with 600. So let's take a quick look. And now the second row entry of verbal score has been overwritten as 600. And in fact, you could do that for the entire column if you wanted. So here I have the same entry, except I don't specify a row. And if I run that, it will now replace the entire column. So nice little shortcut if you need to do a mass replacement. Let's try something else. Let me make sure. Do what I think it's going to do. Yes. Okay. So here I'm going to do the same operation, except I'm going to replace. The gender of the second one from male to female. So that's 2 gender, and I'm going to reassign that as female. And let's try one more thing where I'm going to replace, let's say, the name of student 3. Oops. So here, row 3 of column names, and that's student 3, and I want to change that to student 4. Okay, so let's run this one first. Okay, great. No problem. Let's take a look. Great. So we've switched the gender from male to female. Okay, now let's try this with the names. We'll change student 3 to student 4. Okay, and now we have a warning message, and let's take a look at the data. Okay, and we've got NA. What the heck happened here? So if you remember back to the factors, again, one of the more confusing things, right? So factors are categorical variables that have these levels. And so if I actually just look at a column, at a factor column, the levels are student 1, student 2, student 3. So I tried to put in a level that's not specified. And that is going to error out because now it doesn't know what student 4 is referring to. There's no reference in the levels. And so that doesn't work. So if you want to insert student 4 as a replacement, and you want to avoid getting this error, then you need to redefine your column. So there's a couple different ways of doing it. I'll show, I think, probably the more systematically correct way to do it, and then I'll show you how I probably would do it. So so the way that I would, so probably the proper way to do this is to redefine the factors. So it's going to be factor student data $names, and then you would want to include all the levels of the factor that you want. So we had student 1, student 2, student 3, student 4. And so this is, if you remember from the last lecture, this is the way that we create a factor, and you define the levels here. So I think this should work. So if I run this, look at the table, it's still student 1, student 2, student 3, but there's now an extra level for student 4, which means that when I replace student data 3, there's no longer a warning message, and we've successfully replaced it. So this is probably the right way to do it, because you're sort of explicitly specifying the levels of the factor, but it can be probably a little bit more tedious. So I'm going to run this again. So now that factor, or now that level student 4 doesn't exist anymore. We can see that here. Okay, so now that's gone. And this is the usual way that I do this is actually just like this, where I change the names into from factors into characters. Okay, so this gets back to the earlier question of how I would define or redefine columns as characters or factors. So by default, it loads characters as factors. And if I want to change it into characters, you can just reassign the column using the as character function that we had talked in a previous lecture. Okay. If I look at the structure here, you can see that the names are now a character vector instead of a factor. Okay. And then now if you do that, you don't run into any problems with replacement because there aren't any levels. So I can go ahead and do this. And I no longer have any issues, even though that's not a level that was specified initially as in the factors. And if I really want to change it back to a factor, you can do that as well. I'll run this, and now it takes all the characters and it makes a factor again. The difference between this and before is, now the factorization doesn't include student 3, right? Because that wasn't one of the entries when I made this back into a factor. So something to keep in mind. Okay, why do I do it this kind of hacky way instead of doing it as I was saying, probably the more proper way of defining all the levels explicitly? Well, if you're working with a really large data set and you have lots of levels, it can be a pain to write them all out. Maybe you have 100 different levels or something like that. And so if you just do it as character, then you can avoid having to do all that work. But there are possible dangers in doing that. You may run into issues where the factor acts as kind of a check, because if it's not included as the levels, then it's just going to error out or give warning messages. Whereas if you do something wrong in the characters, you won't see any error messages. So one thing to keep in mind. Okay, so that is the first sort of useful tools for referencing. We're going to look at just a little bit more. So as I was mentioning, let's say I want to create a filter. Okay, and what do I mean by filter? So this is a pretty common type of thing that you would do in data analysis. You know, if you're familiar in working in Excel, for example, there are ways to do this as well. And it's probably one of the most useful things is to create filters for your data. So let's say I want to look at all. Let's say, yeah, I want all verbal scores that are below a threshold, say below like 510, which would just return the first entry. Then the way that you do that is through this procedure, which I think can be a little bit counterintuitive. So I'm going to walk step by step to see sort of exactly what's going on. So first of all, student data. Let's look at the column that we're interested in, which is student data. So it returns 500, 620, and 800. So you can directly put in this filter by saying, okay, less than 510. And what gets returned here is a vector of Booleans. So entry 1 is true, entry 2 is false, entry 3 is false. So let me take a quick step back and show one more way we can reference things. So I'm going to jump back up to here, and hopefully you'll be able to connect the dots. So here, let's say I want row 2. So normally we would type something like this. I can also return row 2 by doing something like this. Okay. So that is saying, by assigning a Boolean value, it's saying return the values where it's equal to 1 or true in this case, and don't return the values that are equal to false or 0. And the same applies for columns. So there's 5 columns. So if I want true, false, true, false, true, so that should return columns 1, 3, and 5, which are names, gender, verbal score. Okay, so knowing that, we can now sort of take advantage of this filter, right? True, false, false. So if I want to return entries of the verbal score, let's think about what is happening here. This is returning, just this part here is the equivalent of saying true, false, false. Okay, so that's like just return the first entry. This returns up here a vector 500, 620, and 800. So if I take the first entry of this vector, then we should be returning the value 500. Okay. We can return the entire rows if I don't specify $verbal score, and I put this here. So this will be student data verbal score less than 510, and we want that in the row position. Then you can see what's happening here, right? So this is true, false, false. So return the first row of this table. And there you go, first row. So less than and greater than are both values or function or types of filters that will look at creating this Boolean for a full vector. And there's one other one, if you want to say is equivalent to, we can do that as well. So let me type that out. So that is with the equal sign, but remember, 1 equals is an assignment operator, and 2 equals is checking for equivalence. So probably another one of the most common errors is doing this. But what you want to be doing is this. Okay, so if I look at my data table, or my data frame, sorry, you'll notice that there aren't any values that are exactly equal to 510. So when I run this, it returns nothing, so 0 rows. You need to get the equivalent value in order to return the row. Similar to what we're doing up here, we can do a reference assignment. So if I do something like this, oops. I can replace, okay, so what does this do? This says replace all verbal score values that are less than 510 with the value 600. Okay. So we can see that happening. Let's replace this one. In this case, it's only replaced 1, but if you have multiple values less than 510, all of those will get replaced. So this is another way of doing mass replacement, but with a filter. So it's a pretty powerful tool for manipulating your data. Let's try some nonsense. So let's say, let's take a look again at this one. Now let's do less than 650. Notice that I'm being pretty careful with my commas here. This vector here is referring to a filter for a row in the table, and so I have to have a column. But when I'm referencing a vector, anything with the and I'll separate this so we can sort of visually distinguish. So these examples down here are looking at the table, whereas these examples up here are looking at vectors. So vector example operations in data frame, and this is whole data frame example operations. And so here I always have to specify the comma, and here you don't. If you don't specify the comma, okay, in this case it worked out, but sometimes it won't, especially if you're doing more complex operations. So let's try some nonsense here. So I've asked for a filter for all the rows where the verbal score is less than 650, so it returns these first 2 rows. And let's just see what happens. It says, okay, put a 1 there. And basically what it has done is it has replaced all the values in the first 2 rows, which is the thing that we were filtering for with 1. And then it messes, well, not messes up. This is the expected behavior, right? We get NAs in the columns that are factors because it has replaced them with values that aren't specified as levels in the factors. Okay, so I'll reload the original data frame. And let's not do this, because that doesn't work. Well, okay, I'll leave this here and I'll comment this out. One last thing to show is how to do multiple filters, which is pretty straightforward. Say I want to, okay, let me pull this back up. Say I want to return the rows of the table where they scored lower than 650 on the verbal score, and they also scored lower than 650 on the math score. So let's do that, and all you need to do is put this ampersand symbol, and that will, oops. So that will create a filter that returns both of these conditions. So if I were to do just the first condition, then it would return both rows 1 and 2. But if I do both conditions, row 2 no longer qualifies, so it should return just row 1. Okay, and so that's how you can do a multiple AND filter. Now let's try an OR filter. And that is using this operator, the vertical line, which stands for OR. Okay, and when we do the AND, right, it's saying both conditions have to hold. If we do the OR operator, only one of the conditions has to hold. So in this case, 650 is true for both these two, for the first two. 650 is only true for the first one, and because it's OR, it'll take the first two. So this should return 2 rows and not 1 row like before. Okay, great. And so we see that happening. Are there any questions? No questions. Okay, so we will continue moving on. Let's see. I'm going to load in some data. So this, actually, I'm going to go ahead and use this option that I talked about before, strings as factors. I'm going to put it as false. So this data that I'm loading in, I'm loading in via a function called read.csv. And so all you need to do, so this is my workspace that I'm currently located in, the working directory. So all you have to do is point to the name of the file, of the CSV file, and it will read that in. So the course roster that I'm loading in is the Google Sheets form that we completed in the course. And I can look through here, and I can see all of the data. And so what we'll do here is that we'll try and I'll show really quickly, using some of the tools we just learned, how to maybe standardize some of the data. Because, for example, in the year, we have some people loading in the actual year, and then some people loading in like the number of years. In this case, if I look at the took R class, if I wanted it to be just a Boolean, there are some people who are answering no's and yeses. Sometimes they're capitalized, sometimes they're not. And same for some of these entries here. And so there are ways to deal with this. If you were in Excel, you might sort of go ahead and jump into this table and fix things manually, right? But what if, for example, okay, so what if I did something like this? What if you have a really, really big data set? So here, if you guys remember, I'm going to use this rep function, which just means repeat it. So I'm going to artificially inflate the size of this data set real quick. So course roster big. And here we can see, okay, wait. I don't think this is quite what I wanted, because it's a list. Let me see, how would I do this again? One second. Don't worry about this, what I'm doing here. If memory serves, this should work. Oh, other way around. Okay. What am I doing here, or what was I trying to do, and what ended up happening? I was trying to basically repeat this data frame over and over and over again. But actually what it ended up doing was it created a list, and then each element of the list was a copy of the data frame instead of one giant data frame. So I did this function where you can operate on elements of a list, and it does the same thing over and over again. So it's just binding all of those things together. Actually, this isn't something that I've shown, but I'll quickly show what rbind is. That's kind of a useful function as well. So if I do rbind student data with student data, this is kind of a silly example. It binds by row. And you can see, boom, right there. It's just, in this case, it's an exact copy, but you can specify, right, different things here. cbind binds it by column. So this is going to be a little bit weirder because now you have multiple columns of the same name, which is really bad practice. You don't want to do this. And in fact, I'm kind of surprised it didn't error out. But this is just to give you another handy tool of like appending things either by column or by row. Okay, back to here. So essentially what I've done is I've replicated the course roster to a massive, massive thing. So if I go ahead and take a look at this, actually before I do that, if I look at the summary, here it's actually treated everything as a factor. There aren't any numbers, and there are a total of 100,000 times, let's see, 26. So is that right? 2.6 million rows. So let's, actually, I don't want this to crash because in native R behavior, if I go ahead and just type this, so if I just look at the course roster, it's going to return the whole table. And if I type this and hit enter, so because I actually don't use RStudio, I'm not exactly sure what's going to happen, and I don't want to risk crashing right now. But in a native R environment, especially on Windows, not on, it's less problematic on Macs. Actually, there are weird reasons for that we don't need to learn about. Then this could actually take forever to load because it's like printing out 2.6 million rows. So I want to avoid that. It may actually work in the RStudio environment, but I didn't test it, so I'm not gonna try it. So one thing, another tool, really handy tool to look at the data without loading everything, is this function called head. So I hit enter, and by default, okay, wait. I see what happened here. I need to, okay. The do call entered it into a matrix, and it enters the data in the opposite way that it does in the data frame, so I need to transpose it. Sorry. So we'll do that real quick. Takes a while to load. It's a pretty big data set. Maybe I should have just done 10,000 instead of 100,000. But we'll get there eventually. Okay, but I can talk through this while it's loading. When you use the head function, it's going to return the first 6 rows of the data frame. And in that way, you can sort of avoid loading everything all at once. And I can do the same thing here with tail, and that's going to give you the last six, the last 6 rows of the data frame. And if you want more or less, you can actually put that here. If I want the first 5, I can do that, or 10, something like that. And if you want the last 10, you can do that. I am not sure why this is taking so long. Oh, right, but actually, this is a nice little handy tool in the RStudio environment, which actually I don't have the ability to use in my native environment. So this little stop sign here will stop the whatever process is currently going on, and it just exit out of that. Okay, good. And so we don't need to deal with something quite this big. So if I run this again, hopefully this should be way faster. Yeah, 10,000. And then load this as a data frame. I'm actually not sure why it takes that long, but okay. We got there. So if I look at the head, okay. This should not be taking that long. Clearly there's something amiss with the data structure. Let me investigate real quick. This is part of the process is oh, I have 120,000 columns. So I didn't want to transpose. Okay. Why is that happening? Okay. Apparently, I am not so quick on my feet here for doing this particular example, but that's okay. We're just gonna pretend. So I will comment this out, and then I will make a note of it in the class notes, so we can actually see how that works. How do I comment outlines like that? Okay. So what I was trying to get at actually is if I go to my course roster and I'm manipulating this in maybe Excel, I can manually go in and change these values. But that would be way more difficult. You can imagine if you had, 1,000,000 rows, something like that. So you would need to do sort of mass filtering and parsing in order to do this in any sort of feasible way. So just as a quick example, one way we can employ what we were looking at, and actually here I can still do the head and tail thing, right? It's not going to return everyone. So let's do a quick fix of the year column, and then we'll move on to some of the more other packages that I was talking about at the beginning of class. Okay, so the first thing I'm going to do here is that it's a character, but I want it to be numeric. But the problem with the numeric example is that you've got some people like me who put in question mark or question mark here. And that's okay. We don't know what the actual year is. Those will just become NAs. And so if I go ahead and change that to a number, it'll give a warning message that we have NAs introduced by coercion, but that's all right. And I can see here, now it looks as this vector, and when I look at a breakdown of the structure, it will provide here, year is now a number instead of a character, which is exactly what we want. Okay. Now, how would I want to convert these? Let's if I go to the year, I either want to go into this format, the 2020 whatever, or I want to change to the one format. Okay, and so I can sort of think out in English first what I want to do, and then sort of apply it in the code. So let's say I want to change it from the 2000 number into the year, your position as a year. Okay, how would I do that? If we let's see, if we assume that this year is, if we assume everyone is a PhD and it takes 4 years to graduate, then the difference from this year to my current year should be, and let's just say the current year is 2019, will be the number of years that you have left. And if it takes 4 years, then you can subtract, then you can do the total number of years minus the years that you have left to indicate the year position that you're in. So let's go ahead and do that. So we want to change the years. So let's say, actually, I think the average is 5 years. So 5 years minus the years that you have left. Okay, and so the years that you have left is this quantity minus 2019. Okay, if I do this, this should provide the corrected year values, but there's one thing that we're missing, which is I only want to do this for all the years that are in one form. Oops, just get rid of this. I only want to do this for the years that are in the 2000s rather than the ones and twos. Okay, so we have to perform this operation only on a subset of these, which is, let's just say, greater than 2000. So we're almost there, but not quite. There's one more thing that you have to do, which is actually this. So this entry is the full vector of 26 values, but we don't want the full 26 values here either. In fact, what will happen if I run this is it's going to error out. Actually, for a different reason. Uh-oh. Hang on. So first of all, So there's two issues. There are NAs, and you're doing NA minus 2019. But actually the other reason is because the length of this is 26, whereas this is some smaller amount because you're taking only a subset. So I also have to do this. So I think because of the NA thing, this is still not going to work. And so what I want to do is to also filter for the non-NAs. So there's a way that you can do that, which is with a function called is.na, and this will return true for the ones that are NA and false for the ones that aren't. And you can do the inverse. Actually, this is something that I haven't shown yet. So if you have an exclamation mark, it will invert any vector of Booleans. So now it'll do something like that. Okay, I'm actually going to show something slightly different because this example actually is turning out to be a little bit more complicated. You can get rid of NAs by using this operation as I've shown above. And so in this case, what we're actually going to do is we're going to rewrite course roster, and we're going to get rid of any rows that contain NA inside of year. Okay, and now I've run that, and now you don't have that issue. So if we go back to this example here, now this should be doing what we want it to do. And I can take a look. For year, the maximum is 5, and this is in a numeric. And if I look at the data, now we've gotten rid of these. Okay, great. Yeah, so it's kind of difficult for me to gauge without seeing you guys. Oh, wait, I see a quick column. You can do NA omit in the code, so we still save the cases. Actually, I'm not familiar with na.omit. Summer, do you want to type out how you would do that? Would it be na.omit in as a function across the filter that you want? If you don't mind typing that out in chat, that would be great. Yeah. So, but anyways, for me, it's kind of hard to gauge how you guys are following this because I can't really see people, and the Zoom environment is a little bit less straightforward to do that. But I would say, hopefully, if this is going too fast for you, all of these tools, we're sort of building them up step by step. And it would be useful for you to have a pretty good understanding of how to do this. And so if it's going too fast, review the notes and hopefully you should be able to follow these steps to build up to eventually doing exactly what it is that we were trying to do. This last part that I went through pretty quickly, this is even though I went through pretty quickly, this is following the logic of everything that we've done before, right? This really, what I'm entering here is just a vector of Booleans, true and falses, and so I'm basically saying return a certain subset of rows, the ones that are entering true and omit the ones that are false. And so the way that I've gotten rid of the NAs is through here, the isNA function, and doing the exclam to make all the ones that are NA as false. Okay, I see. Yeah. So that's, so if we look in chat, actually, I'll just I'm just going to copy and paste this here. If I can do that. Wow, it's really hard to copy and paste from the chat. Okay, so so this is potentially one way, a different way of dealing with this without talking the NAs, is you omit all the NAs from the initial call. I can see if this works really quick. Let's load the original data where we haven't dropped the NA yet. Okay. Not quite, but I think it's because, well, no. Not sure. Okay, like I said, I'm not familiar with this function, but maybe I will figure out what this does and do it in the class notes. Okay, so let's make a note to myself. Fix this. But you can see here, I'm kind of going step by step through what I know to sort of apply that into the specific filter in doing a particular mechanism. And trying to carry that out. So a lot of the like base knowledge and logic that we learned from the earlier steps are, we're just building this up in combination and applying it in certain ways to do what we want. And as you get more familiar with doing certain types of operations, right? Referencing data, creating filters, doing replacements, and then doing that in a really sort of targeted way, it becomes a really powerful tool to manipulate data, handle large data sets, and you can imagine like trying to do something like this in like Excel. Okay, it's definitely doable, and there are ways to manipulate large data sets. You could, create a new column and have some function that you sort of click and drag all the way through, similar to maybe applying a function here. But as you're working with larger and larger data sets, it just becomes slightly more cumbersome. And as the types of manipulations and functions become more and more complex, it just makes a lot more sense to do these types of things programmatically. So even if these examples aren't super clear to everyone, learn the tools well, and then you should be able to apply that through experiences as you do your own sort of data manipulations in the future. And definitely, if you're new to R and you're new to programming, this it takes some time to learn, but the best way will be through application, which is why through the homeworks, it'll be hopefully pretty easy, or not easy. It'll be useful to work through a lot of these problems and filtering because as you move to working with real data and doing your own research and that sort of thing, I can definitely speak from my own experience that learning how to do this type of stuff has been immensely useful. Okay, so that's sort of my motivational speech for the day. So let's move on with the rest of class to talk about some additional functionality through external program or packages. Okay, and so there are all these functions that we've gone through, right? We've done like data frame even today. What are some things that we've done? is.na, rbind, so on and so forth. Okay, so R has a whole bunch of built-in functions, but there are also functions that other people have built that are really useful, and they've put online, and some of the functionality is actually even a lot more, let's say, maybe not better, or not okay, maybe it is better. I wouldn't say more robust than sort of the base functions in R, which are all well developed and everything, but the functionality is just a lot of quality of life improvements. And so to get access to a specific package, you have to first install it. And so the ones that we're going to be working with today are ggplot2 and data table. Okay. Normally I teach base plotting, but in this case, I'm just going to skip directly ahead and teach ggplot2 because I think that it's a lot better in terms of how to think about it, how it organizes data, and then the actual functionality is there's way more you can do with ggplot than the base plotting functions in R. So ggplot is a package that has plotting functionality to do visualization. Okay, and the other one here is data table, which is kind of my go-to replacement for data frames. I actually almost never use data frames anymore. It does everything that data frames can do, but also it does a lot of other, it has a lot of other functions. One of the biggest benefits of data tables is that it's way faster. And so when you're dealing with large data, data frames can be pretty cumbersome. And I really, really wish that I had actually known this in grad school. I was actually working with this large vehicle registration data set at the time. It was maybe like 20 gigabytes of data. And I didn't know about data tables until maybe actually even until after I came to Davis, or maybe right at the end of my PhD. But I remember it used to take me, it would take me a whole day to load in the data. And then whenever I did any operations on it, it could take hours to do even, simple manipulations, something like this, to manipulate the data. And then when I used data tables for the first time, what took me about 20 to 22 hours to load in data took about 20 seconds. And so this function read.csv in data tables, okay, actually before I get there, I'll load this just to show you what this looks like. So this will install the packages, and you only need to do this once, okay? Once the packages are installed, you can call them up using this function called library. So typically you would have something like the library right at the top of your worksheet, load them in, you don't need to do this every time. You only need to do this once. Okay, so I'll type a note here. Don't have this code load just once. Here, you need this code to load the package into each work environment. Okay, so I'll go ahead and load these. So the way that I would load in data with data table is with fread instead of read.csv. So actually, I'll just go ahead and copy and paste this. Where are you? Here. But here, it's not going to make a difference because the data set is really, really small. But that's all right. We'll we can just show how to do that. So fread is the equivalent of read table or read CSV. It'll load in a data set and it'll do it very, very quickly. Okay, I should mention there's actually another package called dplyr. Dplyr and data table are kind of similar in functionality, but slightly different in terms of implementation. They are two packages that were basically made by different people that sought to improve the functionality of data frames. So dplyr is actually, I think, a little bit more popular, but I sort of learned data tables, not for any sort of particular reason. I just sort of want to mention this for those who use one or the other. You know, the functionality is pretty close. There are a lot of like people who are really obsessed with this sort of thing, where they're trying to clock the speeds of dealing with certain types of data manipulation, and you want to get the most optimal. But at the end of the day, they're both really good at working with data. These two packages for all the Python people are kind of similar to what pandas does in Python. These are the two most popular. Because I'm most familiar, I'll teach things in terms of data tables, but I kind of would encourage folks to lean on these two. I guess I'm a little hesitant about saying don't use data frames at all, because they are built in and it's handy to know how they work. But these kind of build off of data frames, and so I would encourage you to use these. I'm going to put in a hyperlink here, actually, which is pretty useful. So this link here is a nice little guide that folks put together that tells you how to do things in data tables and in dplyr. And you can do the equivalent of each of the packages. It's actually this nice little thing where it shows side by side. Here's how you would do this particular type of thing in data table, and this is how you would do it in dplyr. And so I totally advocate for doing one or the other. And if you want to learn how they're sort of related, you can use this guide. Okay. So let's take a look at some data. I think I'm gonna, because of the time issues, I'm not gonna show too much about data tables. I'd like to do some at least basic visualization, and there is actually one other item that I think is important that we want to that I want to teach first. Yeah, so I actually may not have entirely enough time to do ggplot and some of the data table things. So maybe we'll take some time at the beginning of the class next time, even though I said today was our last R tutorial. We'll spend a little bit more time next class to wrap up these packages. Okay, the thing that I want to talk about is something called merge. Okay, and actually we're gonna show first manually something slightly different. Okay, so let's suppose I have two tables. Table 1, which is going to look something like this. And table 2, let's have okay, so let's see. I'm making these two tables. And we're going to have these values here. Okay. Let's say this will be 6, 7, 8, 9. There's a function in R called merge, which will combine values of two tables. And this can be really sort of handy. I'm going to actually show an example of this merge in just a moment and how to implement it. But I think in concept, it's important to understand exactly what is going on here. So there are different types of intersections. Okay, and so let's say I want to join two tables together. There are 4 different ways I can join these two tables together. Okay, so I'm going to just draw this Venn diagram. Actually, I should, it'll be easier if I call this X. Okay, so what are the 4 ways that I can put these together? So the first way is called an inner join. And that is the combination of values where you have everything, where you only include things in the tables that are overlapping. Okay, there is something called a left join. That will include both the things that are overlapping in table 1 and 2, but it also includes everything in table 1. Then you've got what's called a right join, and that's going to include everything in table 2 as well as the values in table 1 that are intersecting with it. And then you guessed it, there is the outer join. Okay, and so this is everything, contains all the data. Okay, what the heck does that mean? Let's take a look at this exact example here. And we're going to just go through each of these four and draw the tables. So what I'm going to do is I'm going to do a join based on the values of my common column called X. Okay, which means I will now have a table X, or a third table with a column X, a column Z1, and a column Z2. Okay. In this table, I'm going to look at the intersection where I have matching C's or matching values of X's, and I'm only going to return those. So that would be here and here with this and this. So here I would do C and D, and then I would return 4 and 5 here, and 6 and 7 here. So this table is the result of the inner join of tables 1 and 2 on X. Okay, let's do the left join. So the left join here, X, Z1, Z2, and now remember, we include everything in table 1. So A, B, B, C, D. And this will be 1, 2, 3, 4, 5. In the C and D, where it does intersect, we'll have a 6 and a 7. But in there are no corresponding values for the rest of it, right? And so here, these are just going to be NA. Okay, and so you can imagine similar type of thing here, X, Z1, Z2. For the right join, we will have, let's see, C, D, E, F. Z1 is going to be 4 and 5 here, and then NA here. And then these will be 6, 7, 8, 9. Let me erase this. And then lastly, for our outer join, this includes everything. So X, Z1, Z2. So this is A, B, B, C, D, E, F. 1, 2, 3, 4, 5. And then these will be NA. And then here, these will be NA in Z2. This will be 6, 7, 8, 9. Okay. So these are the 4 different types of merges. This is another function that is extremely useful to do certain types of operations. Let me re-share my original screen. And we can take a look. At that, at an example of that. Okay, so I thought it might be relevant and interesting to look at an application of this with data that's pertinent to current events. So I've loaded in a data set called coronavirus. You don't need to worry about all of what's going on up here, just a little bit of manipulation. So actually, I'll actually describe what these 2 lines of code are doing. So the original data set contains everything up to deaths, and then you have, I added in these two columns called Phipps State and Phipps County, which breaks down the Phipps code into its constituent parts with state and county. Okay, the reason why I want to do that is I have a separate data set here from the census. So it's got a whole bunch of data here. Let's say I'm interested in, and let me just open this in the window viewer so we can see what this looks like. So in a given sort of state and county, I have all these demographic attributes. So like population. So let's say I wanted to look at something about coronavirus related to the population of the county. So maybe it's something like the number of cases in each county and compared against the population. Well, in the coronavirus data set, I don't have any demographic attributes. So I want to merge the data so that I can have an extra column here, for example, that would say, what is the population? And so that's exactly what I was showing in the merging. And that's this function here called merge. So I will take the coronavirus data set and I'll merge it with the census data set. I'm only taking a certain portion of it. Okay, and I'll just quickly say this notation, if we were working in it looks slightly different because we're working in a data table, but it's one of the few sort of operational differences with a data frame. So if I wanted to do this in a data frame, this is how I would return it in a data frame. And we talked about this, so you should be hopefully familiar with this. So let's see, I'll just write, this is returning the 3 columns in a data frame. In a data table, it just looks slightly different. Okay, you do something like list instead of C. And then you can actually write out the column without quotes, which can be a little bit confusing. This is the one little part that's different about data tables. And so this will do the same thing as this does in a data frame. So the data table equivalent is this. And then what you see below in the merge is this, where I have a dot instead of the list, and that's just an abbreviation. So in data tables, they had this function where you could have this point. Okay. So really what I'm saying is merge the full coronavirus data set with the census data where I only have a subset of the census data where I'm only including the population estimate, and then the codes that I want to do the merge on. So in the previous example, or the handwritten example that I just showed, we merged based off of the column X, okay? And they had the same name, and so they overlap. You don't actually have to have the same name. You can overlap by whatever you want. And in this case, I'm overlapping with what's called Phipps.state in the coronavirus data set, which is the X. And then in the census data set, it's just called state and county. So you can merge on multiple columns. And so you would just specify all the columns here in the by. And actually, if the names happen to be the same in both data sets, you don't have to do by X and by Y. You can just do by and list out the columns, and because they're the same, it'll know what to do. So again, so this will combine those data sets so that I can add the population column onto my coronavirus table. Okay, so the four types of merges or joins is the inner join. So that is the default. Left join is all.x equals true. Right join is all.y equals true. And outer join is all equals true. So if I omit this thing, it's going to take only the values that are contained in both the coronavirus table and the census table. If I do the left join, it'll take everything in the coronavirus table. If I do the right join, it'll do everything in the census table. And if you do the outer join, it'll do everything in both tables. So I'm going to create a new table called coronavirus full, cv.full. Let's take a look. Okay, great. So it's exactly the same as before, except now I have a population estimate here. Okay. I think I'm going to end here because we're sort of right at the end of our time. And next class we'll start with this, and I'll show some quick, neat visualizations using this data set, so we can see immediately some applied use of what we've learned to do some visualization and actually a little bit of data manipulation as well. In the meantime, are there any questions?
Hi, Ellen. I have a question about the X and Y.
Yep.
Since you're joining based on two vectors, the state and county.
That's right.
So if I only use one, for example, if I only use state, then what would be the difference?
Yeah, let's take a look. Okay, so what happens if we only merge on one? Let's see. Before I hit enter, let's think about, in theory, what we're looking at. So if I go back to my example, xz1, xz2, the combination of state and county in this case uniquely identify every row, which is to say that if I use that as like an index or key, you would never, if I use both columns as an index or key, you would never repeat the same state and county. If I only use one, then I may actually repeat, right? And so in this case, you might have something like A, B, 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 1, 2, 3, 1, 2, 3, A, B, 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 4, 5, 6, 7, 8, 9. And if we think about what we did before, now we're about to get really confusing, right? Because you have multiple A's to merge on and multiple B's. So how do I assign Z1 and Z2, right? So let me clear this. So let's take a look at what happens. And I'm going to actually get rid of, we're going to do an inner join first. So it errors out. It's saying this particular thing, which you'll see is the key thing. The number of rows of X and the number of rows I, they don't correspond. And so if I did try to merge them, I could create various combinations of it, but maybe that's not what you want to do. And so you're actually going to get an error because you're not doing unique ones. Okay, maybe you do want to do like a Z1 of 1, 2, 3 with a Z1, Z2 of 4, 5, 6, where you would say Z1 and Z2, you want every combination. So 1 goes with 4, 5, so it goes 1, 4, 1, 5, 1, 6, and then you go 2, 4, 2, 5, 2, 6, and then 3, 4, 3, 5, 3, 6, so that that combination of 3 and 3 differences for A's will result in a giant table of 9. So you can do that if you say all equals true. And that's the outer join, and it says, give me all the combinations. So, oh, actually, I need to, actually, there's one more thing you have to do, allow Cartesian, which is basically ensuring that you do want all the combinations. Okay, I want to make sure this isn't too big and it's not going to crash my computer. Okay, it should be all right. Yeah, okay. So now this table is going to look a little weird if I open this. Yeah, because it's like it's merging by state, and it's going to do every possible combination of state codes. So 1 here, FIP state, and where's the state code? Oh, actually, it doesn't put in the Y one because it's the same. But yeah, it's going to have every pairwise combination of all the like counties internally, because that's the other unique identifier. Okay, so hopefully that answers your question.
Yeah, that's interesting. Thank you.
Yeah. Typically, this isn't too common to do. Sometimes you'll do it, but usually you'll end up doing stuff like this, either inner joins or left or right joins. Okay, I see a question. Can we take a mean or sum value for merged columns? Actually, I'm not entirely sure what you mean. So you can so you can sum and you can do means of columns themselves, and you just use the functions that I've talked about before. I'm not sure what it means to do it on a merged column. Ilham, if you want to give an example or something, I'd be happy to clarify that. Otherwise, you can shoot me an email, or I can make an announcement on Canvas about that question if it's clarified. Okay, otherwise we are slightly over time, so yeah, if anyone has any further questions, especially if you go through the notes, take a look at this stuff, make sure you understand this, and if there's anything really confusing or anything messed up in the code, let me know, and we'll cover that in the next lecture. Yes, okay, I see. So for instance, in the same X values, we sum the Z values. Okay, yeah, so that's actually some functions that I want to talk about with data tables specifically next time. The reason why I was confused is that we don't traditionally think of that in terms of the merging. It's a separate type of question. It's more of what we call a group by question, but it is a super important and useful set of tools, which I'll show next time. Yeah, this is actually one of the main reasons why I switched to data tables from data frames, is to deal with this particular issue that Elham is bringing up in chat. But we'll go over that.
Hey, Alan, real quick.
Yep.
Is the homework posted on Canvas? Or maybe I just missed at some point in the last lecture where I can find it.
It's not posted yet.
Okay.
Is it I think on the syllabus, is it supposed to be today?
I think it was last week, but I don't.
Oh, last week.
I didn't even notice that until today. So.
Okay, well then I'm gonna push everything back. Yeah, don't worry. I will make an announcement on Canvas. It'll be posted on Canvas. Yeah, sorry, I must have totally just blanked on that. It's because in my other class the assignment comes out this week. So and we were told not to give assignments on the first week by the higher ups because of the we want people to learn Zoom. So yeah, I will make sure to put that up as soon as possible.
Awesome, thanks. Just checking.
Yes, office hours. Yes, I was going to announce office hours once I post the assignment, which I hadn't done yet. I will have online office hours, and I need to figure out my schedule and post that, but I'll let everyone know on Canvas. Okay, great. Thanks, everyone. Sorry for going over time a little bit, and I will see all of you on Thursday.
Thank you,
Awesome.
Alan.
Thanks, Alan.
Yeah. Oh, last question. I see. Can we use other languages on homework besides R? Yes. And I'll actually make an announcement about that as well. The format of the homework that I want submissions in. So yes, you're allowed to use other programs, programming languages. Okay. Bye, everyone.